Good morning, good afternoon, everybody. My name is Raman Sridharan. I'm product manager for vibration controllers, and today we're going to have a quick presentation on automation with the REST API. So the agenda for this presentation is we're going to go over the REST API. We're going to get into what you can actually do with the REST API, and then go into some examples of how to use the REST API with SignalCalc 900. And just show you some examples in Matlab and Visual Basic. Okay, so jumping right in, what is the REST interface or a REST API? REST is basically a generic way for different programs to talk to each other. So if you're a software engineer, or you have an internal automation group that writes software that automates your entire lab, the REST API is how your software would talk to our software, our SignalCalc 900 software. And through this interface, you can command our software to open tests, run tests. You can get statuses and things like that. So it's a complete tool to enable a user to write software that would then control our software. So, for example, if you're a programmer writing a phone app that wants to communicate with LinkedIn, that's where you would use a REST API. That's an example of where you would use a REST API. It's just a generic way for different pieces of software to communicate. The REST API works over a network, so you can write your software to talk to our controller or analyzer software, and you can be running anywhere across a network or across the internet and still have that communication between the two. And pretty much every current programming language supports the use of the REST interface or REST API, and that includes things like Matlab, LabVIEW, Python, things that are more geared towards data science and data acquisition, and other languages also support it. So if you're doing things like web applications or Visual Basic or C, C++, C#, those also all support the REST API. So it's one of the most generic interfaces out there. So no matter what language you're running and what environment you're developing in, you'll be able to use it to talk to SignalCalc 900. So that's a generic overview of what the REST interface is. For those of you that are not familiar with this tool, now I'm going to jump into what you can actually do with our software, with SignalCalc 900, through the REST interface. So the REST interface implements a lot of basic functionalities that are within SignalCalc 900, and the goal of all of them is to give you the tools to automate processes that should be automatable. Or if you have a lab and you want to synchronize different systems or have your own user interface that will interact with our software in the way that a user normally would, that's sort of what the REST interface functionalities enable you to do. So the types of commands, this is a shorter list. We have a longer list of commands, but the shorter list, the concise list here, includes things like reading your list of test profiles. So if you're familiar with SignalCalc 900, you'll have your manage test button, which has your database of tests. So getting that list of tests, opening a specific test in the run test page. You can change parameters. For example, you can set the input channel sensitivity of one or any specific channel. You could change some of the test parameters, like your sample rate or sampling or block size. You can control the SignalCalc 900 software with the test controls, like the initialize button, start button, stop button, and end buttons. For vibration control tests, while a test is running, you can, through the REST API, you can execute the manual mode controls. So things like, stopping your sine sweep, if you're running a sine sweep, stopping the frequency of the sweep or changing the amplitude of the sweep can all be done programmatically through the REST interface. You can read the status of the test that's currently running. So you get things like elapsed time, start time, remaining time, test level. You can also read and write through our digital I/O card. So if you're using the relay card to talk to, for example, a thermal chamber or another piece of lab equipment, you can access, read, and write that relay card that normally is read and written through our software. You can have full control over that through the REST interface. Some of the other functions from the REST interface that have to do with data, or you can grab data as data is coming in through the controller or analyzer. You can grab a live snapshot of your data, or you can open up a run in review mode and grab data from that run. So you can review historical data also and transfer that data all through the REST interface. So in short, the REST interface allows you to develop your own application to automate your lab. You can write the application in your preferred language, whether that's Matlab, LabVIEW, Python, C, C++, Visual Basic, and you can do all that while still leveraging the power of SignalCalc 900. So all the tools, the bells and whistles that we have in our SignalCalc 900 software suite and the 900 series hardware, you can still take advantage of all that while still having full control of your lab's automation. All right, with that, I'm going to jump into a few examples. Let me just bring up SignalCalc 900 here. So you can see I'm in my managed test page, and the test I'm going to be demonstrating here is this test called random vibe. So this is a random vibration control test. So let me just open it up and do a quick overview just so you know what kind of test I'm running. So the test is called random vibe, and if I look at my input channels, I've got one control channel, which is a TEDS accelerometer, and I've got 3 other accelerometers enabled. Now, one thing I'm going to point out here, because I'm going to demonstrate changing it through the REST interface, is my input channel number 2 sensitivity is currently set to 100 millivolts per G. So I'm going to just demonstrate changing that in the REST interface, but so keep that in mind. And my random profile is just a flat random profile running on a small shaker here on my desk. It's a 0.05 GRMS, just a low level 10 to 2000 hertz profile. Okay, so I'm going to close the test first here. So I'm just going to be as if I just opened, it's going to be as if I just opened the SignalCalc 900 software. And the first example I'm going to show is going to be a Matlab automation example. So we provide, if you buy the REST interface option and are programming in Matlab, we have a Matlab class that handles all the low-level commands to our software, and you're left to use a very easy to use, very simple list of commands here. So, for example, I initialize the DP900 REST object, and then I'm going to say my test name is random vibe, which is my test name here, and I'm just going to call open test. So from within Matlab, I kind of have Matlab open here on the side, on the right side of my screen, and SignalCalc running in the background. So as soon as I issue open test, executed it, you can see it opened up the random vibe test as if I'd gone and double-clicked on it in the software. So here's another command. I'm going to open up the test editor and change my input channel parameter for my input channel number 2. Remember, it was set to 100 millivolts per G. I'm going to set it to 122 millivolts per G. I'm just going to hit enter and execute that. You can see on the screen that it flashed up momentarily. And if I come back into SignalCalc 900, so I'm going to ignore Matlab for now, I can come into my test editor, and you can see it's been changed to 122, which is exactly what I had asked it to do. Right, so back into Matlab, I'm going to execute the initialize test command. So I'm going to hit execute on that. And there it goes. Test is initialized, and start test. So now my test is actually running. So you can see I'm not going to go through and finish this example. In the interest of time, I'm going to switch over to another REST interface example, but you can see I've got things like getting the test status, which is basically all of your status parameters, reading signal data, stopping and ending the test, and so on. So that's a quick example in Matlab. The next thing I'm going to show you is just a similar example that's written in Visual Basic. This is just a simple, minimize Matlab there, a simple user interface that can be used to command our software. So this is pretty much limited to our test commands. And you can see in here, in this example, I've got test controls, which are grayed out currently because the test is currently running. But all I've done here is written a program that gives me access to the start and stop buttons and reads out the test status at the bottom. So I already showed, initializing and starting the test. But down here at the bottom are an example of the test status parameters that I can pull through the REST interface. So for example, I've got the test status is test running. I've got a readout of my drive voltage, my control level, my reference profile, and then the current test time. So a minute and 2 seconds, minute and 4 seconds. So this is just another example of the REST interface in action. I'm not going to show the source code for this, but it's a pretty simple Visual Basic application. So stop test and end test sends all the commands through the REST interface. The last example I'm going to show is actually I'm going to close this one and open up my last example, which is a Visual Basic for applications macro that's written in Microsoft Excel. So this actually gets included if you purchase the REST interface. You actually we include this file with our software installation, and you have access to it to use it as example or whatnot to develop your own REST interface application. I'm going to pop it over to the side again here, just like I did with Matlab. And for example, again, here I have my start and stop buttons. So let me initialize my test. And there we go. Actually, before I initialize the test, let me end the test. The reason we provide this Excel file along with the REST interface software option is because it gives you the ability to edit your channel table. This is the file is called channeltable.xls, and that's because if you look at my tabs here, I have a channel tab for the input channels, an Excel tab for the input channel parameters. And this, if I click on Get Input Channels, it'll load my input channel settings from my currently open test. Now, I've only got 6 channels here. It's not that big a deal, but if you've got, multiple chassis with 200 channels or 100 channels, you can see how this adds a lot of functionality, the ability to edit your channel table in Excel. Just change my sensitivity here back to, down to 10 and change my engineering unit, whatever changes I want to make to my channels table, and click send to DP900, and they're instantly loaded into the current test in SignalCalc 900. So again, loading channel data is one of the things that's commonly automated, so that's why I'm spending so much time on it. But let me go back to my test commands here and start the test, get the test running. Test commands, initialize, and then I'm going to show my the last example that I have here that I wanted to get through, which is showing the ability to grab data from the REST interface. So my test has started. Let me let the pretest run. It's going to jump straight into my test. Okay, so my test is running. So now let me go back to my Excel macro file here. Let me just full screen it. This page is a little bit larger. So the last tab I'm going to demonstrate here is the Signals tab. And this actually shows how to get signal data, which is the data that I'm seeing in my plots behind me, out from our application and into Excel through the REST interface. So the way this Excel macro is programmed is I can enter any signal name here. So I have G11 and G22. These correspond to the names in that if you go into SignalCalc 900 and go to the Add Signals tab, the channel name, the signal name here is exactly what I'm referring to. So G11 is going to be my auto power spectrum for channel 1. G22 is the auto power spectrum for channel 2. And then I've also, in my spreadsheet, I'm also calling for the signal X:1, which I don't have it listed here because it's a time domain signal. But if I go to my control time plot here, you can see my X:1 signal is my time domain signal from my accelerometer 1. So I'm going to go back into Visual Basic. So I'm requesting, or my Excel application, I'm requesting G11, G22, and X:1. So I just say load data, and it grabs the current signals that from the test that's currently running and pastes them right here into Excel. So this is a pretty powerful tool to not only have your software automate and control, start, stop, open test, close test, but you can also load data live from our software. And this is particularly useful if you're doing a signal, data analysis or doing some sort of, process monitoring or condition monitoring, you can actually load full Signal data directly through the REST interface into your own application. So now it's in Excel. I can do whatever I want with it in Excel. I can select these and plot in Excel. I'm free to do what I want to in Excel. Okay, so that brings me to the end of my presentation here. I have gone through the REST interface, shown you some of the basic functionalities. We have more functionality than what I've shown today, and we're constantly expanding our list of REST interface functionalities based on the demands that we see out there and on what customers want to do with their lab automation. Please reach out to myself, Raman Sridharan at dataphysics.com, or your local data physics rep. And you can find a lot more information on our products at dataphysics.com.